Smartwatches provide users with access to important information like text messages, health data, weather, and complex data. The key benefit of a smartwatch is that users can access information anytime, anywhere, because of a small form factor and wearability. While the unique size, form factor, and function of a watch has many positive aspects, there are several drawbacks. One of the primary drawbacks is that representing complex datasets on a small display panel can be challenging. Smartwatch datasets can be particularly complex as they continually collect data. A common time series graph often produces a level of detail which can be difficult for users to understand and glance, but also hogs screen real estate. Both of these drawbacks run counter to the benefits of the smartwatch, which are that they are glanceable and easy to use while multitasking. We propose a new technique, the space-filling line graph, or SFLG. The glanceability of the watch is maintained by simplifying the line graph being represented, which opens up free space. Next, a greedy algorithm is applied to identify these empty regions of the screen, which are used to represent additional information. In this paper, we conducted 2 studies aimed at measuring efficiency, user preference, and the legibility of information. In the first experiment, we compared 3 types of line graphs: non-simplified, simplified with PIP, and SFLG. We measured the performance of participants in the study by recording their response time and accuracy in performing tasks related to understanding the graphs. For all tasks, we found that SFLG produced faster response times among users. We also asked participants to rank the 3 graphs based on subjective preference. We found that over 50% of participants chose SFLG. For experiment 2, we focused on the space-filling aspects of SFLG. For the experiment, we compared the SFLG model with non-simplified graphs with additional graphs added, and swiping between separate graphs, which is the current most common style of interface. For all tasks, we found that SFLG produced faster response times among users. Extra space around a graph can be used to represent detailed information by tapping on a specific area of the graph. A user running between appointments may want to look at their heart rate data. To compare a spike in the data, they tap on 2 points on the graph to bring up more detailed information. Users may also wish for more efficient access to notifications, which are often intrusive. Placing a notification in the space around a graph allows for simultaneous access to notifications and line graph data. Lastly, we wanted to apply the SFLG to a streaming data set. Here, we animated the detailed information in 2 separate ways. First, we simply faded the extra information off of the screen. This allows for the detailed graphs to remain in place with a chart and selection. Second, we used a smooth animation to update the location of the detailed chart. This allows the extra information to remain on the screen as long as the selection.